All right, so in the last two activities, the first one is titled Charles Law, correct? So we're looking at the volume and the temperature. So I've got two syringes. We're going to start them both out at 100 milliliters. Your starting temperature is going to be 20. Go ahead and record that. So starting temperature 20, starting volume 100. And instead of going through and doing the syringe in hot water and then putting it in cold water, what I'm going to just simply do is put one of them in the hot water and one of them in the cold water. We'll wait about a minute and a half, and then we'll take the volume measurements, okay? Now, so I'm going to go ahead and put these in. There we go. Now, what is the temperature going to be for the one on your left, my right? Temperature, come on, look at it. 100, why? Because it's boiling, okay? Well, I guess I should tell you, it is water, okay? So, you guys boiled water, you measured the temperature of it, it doesn't change, right? So, temperature of 100 degrees. What's the temperature of this on my left, your right?
0 or close to 0?
0 closer. We're going to treat it as 0. Okay? Why? Because we got ice. And what is it doing right now?
It's melting.
It's melting. And the melting point of water point is 0 degrees Celsius. Okay? Okay, so we're going to take at 100 degrees, we're going to take the volume to be 115. And then at 0 degrees Celsius, we're going to take the volume to be 95. Okay. So when we heated it up, the volume got larger, and when we cooled it down, the volume got smaller. Now keep in mind, in this, the things that we're keeping constant are the moles, because it's a sealed up syringe, as well as the pressure. Now the pressure is remaining. For the pressure to remain the same, we need to have the piston move up or down, depending on what the temperature is. So the piston's moving up and down to keep the pressure inside equal with the surroundings. Okay? That's what your containers that you were using at the lab stations weren't doing. They were staying the same volume. So anytime you put more air with the fizz keeper into the 1 liter bottle, I know it says 2 liters, but those are 1 liter bottles. You were getting more pressure, but it was still the same volume because the container wasn't able to expand. Okay? All right, so the last one is Gay-Lussac, is that correct?
Yes.
Okay. Now the Gay-Lussac is the relationship between pressure and temperature. So I have a test tube sealed, so the moles is going to remain constant, and the volume is going to remain constant because we've got a rigid container. What we're going to change is the temperature by dumping it in that hot water and the pressure. And I've got this here that's registering what the pressure is. Right? So, starting temperature, 20 degrees again. Because we're just going to take the temperature of the room as 20 degrees. we're going to take the pressure to be 757. I'm not magical, I'm just looking at the reflection in the camera. Okay, I'm going to dip it down into the hot water, and we're going to let it sit for about 45 seconds, and we'll take whatever it is, unless it becomes stable before that. All right, we're going to take the pressure at 100 degrees. It's being 891. Now stick it down in this ice water. We're going to take temperature of 713. Now you can go ahead and answer the rest of the questions and stuff related to that. Everybody good?